Welcome to Ask and Learn.
An ice-making machine operates in a Carnot cycle, and it takes heat from water at zero, rejects heat at room temperature 24°C. Suppose that 85 kilograms of water at zero are converted to ice. How much heat is discharged into the room, and how much energy must be supplied to the device? Okay, so this is a pretty standard refrigerator problem. So for part A, we need to figure out how much heat is needed. So that's going to be QC. Let me write down actually the latent heat of fusion. Okay, rewind. Latent heat of fusion for ice making is 3.34 times 10 to the 5 joules per kilogram. Okay, it should be included here. Oops. Should be in that box. Okay, so yeah, if we want to convert water to ice, keep it at the same temperature, then QC is just going to be M times LF. So it says 85 kilograms times 3.34 10 to the 5. And if you do that calculation, maybe you'll get the same thing I did, which is 2.84 times 10 to the 7 joules. So that's how much heat is drawn from the cold reservoir. So for part B, we want to get the work. So if you look at the section on refrigerators, you'll see that the formula you want to use is the magnitude of the work is Q hot minus Q cold. And that just kind of comes from a energy conservation perspective, knowing that the work is negative, the heat going in, it comes from the cool reservoir, and the heat going out goes to the hot reservoir, so it's negative. But anyway, this is the formula that you need to use. We also need to use this formula for Carnot cycles in particular. So that's Q hot is QC TH over TC. And then if we take that and plug it into there, then the equation just looks like QC times TH over TC minus 1. TH is the 297, TC is 273, and then QC is what we calculated in A. Ooh, now that I'm thinking about it, I'm going to box it. Okay, so if you go ahead and plug that into a calculator, you might get what I got, which is 0.25 times 10 to the 7 joules. And this quantity is negative, but I'm just going to worry about the magnitude, kind of in line with how it's formulated in the book.